Well, hello for the second time this week. What was new this week were the nonparametric statistics tests, the sign test, and the runs test that you did in the previous video. This one is going to kind of sum up everything that we've done. Because the question that we're going to answer now is, which test should I use? You guys know that whenever I have asked you to do statistical tests so far, it's always said very specifically in the problem what kind of test you were supposed to do. Back when we had like 5 different Z and T tests to choose from, it would specifically say do a 2-proportion Z test. So you knew exactly which kind you had to do. Very reasonable question, though, would be if I had to do statistics for my job, how would I know that? Is it going to tell me what I have to do then? Well, probably not, but there's some pretty good rules that you can follow, and that's what this part's about. Before I get into talking about all the different tests and going through some examples with you, I want to mention a couple of specific distinctions. In the names of the test, some of them say sample and some of them say proportion. There was, for example, a 2-sample t-test and a 2-proportion z-test. Anytime you have a test with sample in the name, what you're doing is comparing averages. And in the problem, it's going to say something about average and standard deviation. Anytime you have a test with proportion in the name, you're looking at percents. It's either going to have some percents in there, or sometimes it might say something out of something. But sample tests deal with averages, proportion tests deal with percents. The other big distinction is 1 versus 2, which sounds kind of dumb, but it is actually an important distinction. We had like a 1-sample t-test and a 2-sample t-test. The difference between those is that when you do a 1-sample test, what you're doing is you're looking at one group and you're seeing is the average there different from what it's supposed to be. Either like different from what it is worldwide or different from what it used to be, different from what you'd expect. On the other hand, a 2-sample test, you're comparing 2 separate groups, like men and women, or blacks and whites, or otherwise 2 completely separate groups. So 1, it compares one thing with what it's supposed to be. 2, you're looking at 2 separate groups. And with that in mind, I'm going to try and point out the most important things, sort of the giveaways to look for when you see problems that are asking you which test you should use. You have a handout that I'll be going through the answers from at the end of this video that you notice is a bunch of multiple choice questions where it gives you a little situation and says which of these would be the correct test to use. That's exactly what you're going to see on the final test too, are questions exactly like that. So hopefully I can give you an idea of what to look for so that you can find those to be easy problems instead of impossible ones. So one of the first tests we did was what your calculator calls a t-test. It's what I often call a 1-sample t-test. And a 1-sample t-test, you have one small sample. Remember, t stood for tiny. You always had to have less than 30 in your sample. And you had a problem that was somehow asking about average. A t-test was different from a 1-sample z-test because z, typically you had a big sample. The other possibility, if you didn't have more than 30, is that you might have information about the standard deviation of the population. If you have phrases in there like according to the US Census, where they have something where they're very likely to have information for the whole country, that's kind of a giveaway that you're likely to have Z as well. Anytime it's a sample test, the problem's going to ask about average, and again, T is small, Z is big. A two-sample t-test, you were literally looking at two samples. You want to know, is the average of one of them bigger than the average of the other? In the problem, they're going to give you two averages and two standard deviations, or in the situations you'll have on the worksheets and tests, it'll at least talk about two averages and two standard deviations. And those two separate samples, that's why it's a two-sample t-test. Proportion, again, means percent. So a one proportion z-test, what you're looking for is the percent bigger or smaller than what it's supposed to be? If you see percents in the problem or you see the phrase out of, that's kind of a dead giveaway. It's going to be one of the proportion tests. And again, a one proportion test, you compare what the percent actually is with what it's supposed to be. A two proportion test, you look at two different groups and you want to see, is the percent of one bigger or smaller than the percent of the other? This time they are likely to have different percentages that are given, but again, percent and out of tend to be proportion tests. Much more recently, we started looking at chi-square tests. And one of those was a categorical or a goodness of fit chi-square test. It's called categorical in the problems that you're looking at on the worksheet and on your test. What happened with a categorical chi-square test is you always had more than two categories. This is the one where you're looking at like different colors of M&Ms. You have more than two categories and typically you're counting up how many there are in each of those. Sometimes you're given a whole bunch of different percents in the problem because what you're looking at is the distribution we have different from what all those different percents are saying that they're supposed to be. More than two is always kind of your dead giveaway for categorical test. The other kind of chi-square test that we did was what was called a matrix chi-square test. When you have a matrix chi-square test, your information, it either literally is in a table, or at least in the problem, they talk about how you could put it in a table. You're counting up how many are in each row and column, you put it in a table, and analyzing that table, that matrix, is why it's called a matrix chi-square test. A couple of weeks ago, we did a correlation R test. That was the one where you were looking at whether two different variables were related. The dead giveaways you'll see that tell you it's going to be a correlation R test are words like increase or decrease or goes up, goes down, things like that. Basically, you're saying when one thing happens, what happens with the other thing? And again, increase, decrease, up and down, those are like the dead giveaways for correlation. Just this week in the last video, you learned about a sign test. In a sign test, what you care about is, are there more things in one group than in another? Big thing about a sign test is you're just counting. You don't have averages and standard deviations. That would be a Z or a T test. You just count up how many are in the groups. And the last of the tests we've learned about in here was the runs test. And in a runs test, what it's asking is the data random? Now, that literally will be what it's going to say in the questions you're looking at, but I do want to caution you that sometimes in the real world you may see things where it says, like, here's a random sample, and then it goes on and tells you about it. It's got to be the question is it random to be a runs test? And again, there's a handout that says which test should I use, and you might want to pause the video at this point and take a minute and at least make a stab at all of those problems. And what I'm going to do, starting with the next slide, is go through and try and show you what is the reason for each of them being what it is. You can see the answers over at the left as we go through these. What I'm going to try and do is explain why everything is what it is. And you notice I circled stuff on each of these too. On the first one I circled table. And table, you see that, it's like a dead giveaway. It's got to be a matrix chi-square test, C. On the second one, it's talking about averages, and it talks about the US Census. And again, the US Census means we know stuff about the whole population. That's how I know this is going to be a z-test. Would also be a z-test because even though Whittemore, which is a little town west of Algona, it's a small town, but it's got way more than 30 people. The third one, it again says average, and so that kind of tells me it's going to be one of those tests with sample in the name. And since we're only looking at 12 days for our sample, that tells me it's a small sample. And that's how I know we've got one small sample. It's a one sample t-test. And then number 4, I circled average and I circled both, because this means I know the average for Chevy and I also know the average for Ford, and we're going to compare those. And that's why it's got to be a 2 sample t-test A. On the next one, I circled goes up and goes down. When you see that, it's like the dead giveaway for a correlation R test C. I always get a laugh out of number 6 where we think the priest isn't picking those bingo numbers randomly. But on this one, since they want to know whether or not it's random, that's why it's a runs test, and it's going to be D. So number 7, I circled small, moderate, and large. And the reason I did that is it's showing me that we've got 3 different categories. There's also 3 different percentages that are given in this problem, and they want to see if this distribution is different from what it's supposed to be. Well, the 3 categories is why I know that this is going to be a categorical chi-square test. Small, medium, and large insurance claims are just like different colors of M&Ms, so C. The next one, we know the mean, and that's like the average, and the standard deviation of 2 different stock exchanges. And so that's why it's a 2 sample t-test. It's going to end up being C. Both number 9 and number 10 have percents in the problem. And that kind of tells me that both of those are probably going to involve proportion. And so you can kind of get rid of the others and focus in on the ones that are proportion. The difference between these two is that on number 9, we're looking at 23%, and we're trying to see if what we actually have is less than that number. On the second one, we have a percent of whites and a percent of blacks, and we want to see if they're different. That's why the first one is a 1 proportion z-test, C, and number 10 is a 2 proportion z-test, which is going to end up being B. Then when you go down to number 11, again we've got like went down, and that kind of tells us it's going to be a correlation R test. On number 12, we want to know about the percentage, and we want to know if Spencer is higher than what it is nationwide. That's why it's a 1 proportion z-test. What I circled on number 13 were all the different counties where Iowa Lakes is located. And there happen to be 5 of them. 5 is more than 2. And it's different categories is what we're looking at. We're looking at, is this distribution different from what it should be if it's random? And so it's a categorical chi-square test because we're looking at more than 2 different things, B. Third one, we have the words below and above. Sometimes people will look at this too quickly and they want it to be a correlation R test because they think of that as being like goes up and goes down. But this is like one number, and I want to see if it's above it or below it, and that's a sign test. That's exactly like the problem we did in the other video on did he get to work in less than 10 minutes more often than he did in more than 10 minutes. So yeah, sign test D. The last one, you literally see a picture of a table, and that's why it's a matrix chi-square test. So number 16, it says we have a large sample. In fact, it's several hundred doctors. And the question asks about average. You put that together, it's got to be a z-test, 1 sample z-test A. 17, I actually had somebody that did this for their project one year. And she actually looked at, did people use cash or card when they were doing their payment, and counted up how many there were of each. Well, the key thing here is we're just counting, and we want to know, are there significantly more in one group than the other? That's why it's a sign test. That's why it's going to end up being C. The last one, the very last word of the question is random. So we want to know, were these numbers random? And it turns out that's got to be a runs test. And in fact, they did prove that the lottery in Illinois had been rigged back in the 70s. That's why if you watch lottery draws these days, they'll always tell you that this was certified by some accounting firm so that we know that it's fair. You can get more practice with problems like that on the sample test, and you will have some questions like that on test 4, where I'm asking you what would be the best test to use in different situations. So that's part 2 of our videos tonight, and we'll go on to the others.